Hello everyone, welcome back to the channel. In this video lecture we'll be solving this problem, jump game 2. So in this problem we are given a zero indexed array of integers nums which has a length n. We are initially positioned at nums 0, that is the first element of the array. Each element nums I represents the maximum length of a forward jump from that particular index. In other words, if you are at nums I, you can jump to any nums I plus j where j lies from 0 up until that integer on which we are standing, and the sum of these two indices must be less than the size of the array, so that we cannot cross the given array. So what do we have to do with this problem? We have to return the minimum number of jumps to reach the last index of the array. So here the test cases are generated in such a way that we can always reach the last index. Fine. Now in the input will be given the nums array which has n integers, while in the output we have to return an integer representing the number of minimum jumps that we can make. Let's see the constraints of the problem. The length of the nums array may go up to 10,000, while the element in the nums array may go up to 1000. It is also guaranteed that we can always reach the last. So let's better understand the problem statement using an example. So here we have our nums array, and this is the starting position. We are standing at position number 0, and I want to reach the index number 4, which is here, last index, using minimum number of jumps. So here, starting at index number 0, I can make two jumps. The jump of length 1, that is 0 plus 1, that is this jump, just move to the next integer 3, or the jump of length 2, that is move to integer 1 here. So which jump I would make? Let's say I make this first jump, so I move to integer number 2, so I land here. From here I can go to the next integer, I can go to this integer, that is I can make two jumps, or I can make a jump of length 2, or I can make a jump of length 3. So which jump I will make while standing at this integer? Obviously I will make the jump which is longest here, which lands me on the last integer, because that will end the process. Hence I will make this jump which is the longest jump and land at last, which will eventually give me the total number of jumps, as because I started at the first integer 2, I jumped to the second integer 3, then I jumped to the last integer 4, and which eventually counts to 2 jumps. Fine, which is the answer, because these are the minimum number of jumps that I require to reach at the last index. Fine. Now how can I solve this problem? So in the very first look, it may seem to you that this is a dynamic programming problem. It can be solved using dynamic programming approach, but there is a better way, or we say a more optimal solution, which works in a linear time complexity big of n, and it is greedy as well. That means we do not have to use extra space as we use it in dynamic programming. All we have to do is to just build our greedy solution and solve the problem. So let's think about it. So we start at integer number 1, that is this one. I can land to the second integer by making a jump of size 1, or to the third integer by making a jump of size 2. So the range that is covered by this integer is, okay, so this is the range which is covered by the first integer. Fine. Now what I'm saying, while making exactly one jump, I can cover this range. I can jump to any integer which is present in this range. That's what I'm saying. It doesn't matter on which integer I land. So now let's see the integers in this range. Let's say I jump on first integer of this range, which is 3. Now standing at 3, I can make jump of size 1, that is landing to the right next integer, a jump of size 2, or a jump of size 3. Now what is the range that is covered by this integer 3? The range is this one. Fine. The range is this, because I can land to any of the integer which is present in this range. Fine. So standing at the first integer, I can jump to any integer in the second range. Then from one of the integer in this second range, I can reach to any integer in this third range. Any integer means even the last. So how many jumps would it take to reach the last integer? Obviously 2, because we have three separate ranges which we can navigate starting from the first range, that is the first integer. So the first range contains the single integer, that is the first one. Then I can jump to any integer in this second range, while from the second range I can jump to any integer in this third range. And we know that the third range contains our destination integer. I will obviously jump to the last, which will eventually give me the final number of jumps as 2, which is the least number of jumps. That's the idea. Very simple. So how would I, so just try to implement the solution right from here if you got the intuition to this problem, because that will eventually help you to understand the solution better. So let's see how we can solve this problem. So take 2 pointers, take first pointer as left, take another pointer as right. Initialize both the pointers with the first index. So right and left are initialized to 0. Fine. So we are standing at the first element. Now all we have to do is just find that starting from this index, how far I can jump. I can see that from this integer I can jump up to third integer, which will eventually cover a range of 2 integers, which are these, that is 3 and 1. Okay, so this is the second range. So this is a range which I can cover while starting from the first integer. Then, so left and right define the pointers in the window. So in the very first window, left and right were at exactly 1 integer because the window contained only 1 integer, that is the first one. Now in the second window, I have 2 integers, 3 and 1. So the left moves to the left corner of this window, that is the left side, and the right moves to the right side of the window. Fine. Okay, so these are 2 pointers, left and right. Left points to the starting of the window, while the right points to the end of the window. So this is the new window on which I am standing. Now from this window, I will iterate, that is, I will move the left pointer till the right pointer, and for each integer I am iterating, I will check how far I can go. So initially I am at this integer 3. I can make a longest jump of size 3, that is 1, 2 or 3. That means I can reach last integer. I can reach till this point. So what is the range that I can cover while standing at the second integer or this? So till here I have made 1 jump, and the next range would be this. Fine. Because this is not included because I can reach this integer by making exactly 1 jump. So it is same as reaching 3 as reaching 1. I can reach either of them in exactly 1 jump. Fine. So the next range which I am focusing is this one. Okay, so then I move to this integer which is 1, and from this position the longest jump which I can make is of length 1. That is, I can just move to the next, which we have already covered. So for that I will keep track of the longest range in a variable. Let's call it farthest. Okay, so this is the variable where I will be keeping track of the last integer which I can reach. So initially the farthest is 0. While I started iterating from the first integer, the farthest will become 2 because 0, 1. The second index is the final index which I can reach while starting from the first index, which is this one. Then standing at this 3, the farthest will become this last integer, will become this last index. Fine. So that's the utility of this variable. That is to update this right pointer. So after I cover this range, I have to shift these pointers to the next range. For that I am using this variable. Left will simply be shifted to right plus 1, while right will be shifted to farthest. Fine. Now the left will be here and the right will be here. Since the right points to the last integer, I no longer have to shift to the next range because we have already arrived at the last integer. So while doing these shifts, that is shifting from one range to another, I just want to count the jumps, and the jumps are simply these range shifts. And for that I will keep another variable. Let's call it answer variable, which I will initialize with 0 here, and it will be incremented by exactly 1 while shifting from one range to the next. So I shift 2 times from here to here, then from here to here. So the answer will become 2. So I hope you got how to implement this solution. Pause the video here and try to implement the solution by yourself. And after that, come back to the video. Okay guys, this is my implementation. This is jump function which takes in the nums array. Okay, so and here I initialize my answer with 0, the answer which will be counting those shifts, that is range shifts, which I discussed in the previous slide. N will represent the size of the nums array, left represents the left pointer in the current range or window, while the right represents the right pointer in the current window. Initially the window contains the first integer only, then I run till my right integer reach the last index, because whenever this right variable reach the last index, I no longer have to shift to the next range because there is no next. Then I initialize my farthest variable, which will be used to perform these range shifts. Initially it is initialized to 0. Then here I am updating this farthest variable simply by checking how far I can go while I stand at. Okay, so this I actually starts from L or left. So here it starts from left, it goes till the right, and I update my farthest variable, how far I can go from any index I. So here I is basically iterating my range left to right. That's all this I is doing. Then I will shift my left variable to R plus 1, which is right plus 1, and R will be shifted to the farthest. So here I am making the range shift. I am updating my left and right pointers. So from the one range to the next range. And here I am updating my answer by 1 because I have made this range shift. Finally, I will return the answer. So this is how we solve these kind of problems. This is a greedy solution. Let's discuss the time and space complexity. The time complexity for the given implementation is linear because we are just iterating, because here you can see that, observe that we are iterating over each element exactly once. Each integer in the array is visited exactly once. The space complexity for the given implementation is constant because I am not using any. This is a greedy solution and we are not using any extra space. So the space complexity is constant. Let's see the code implementation of the idea explained here. Okay, so this is my solution class, and in this solution class I will define a function jump game2 which takes in the jumps array, and I will initialize the answer variable with 0 and 2 pointers with 0. So here I'm standing, the first range contains the first integer only. Then here I'm calculating the size of the jumps. Okay, so here I am iterating over the ranges. So this right pointer will go till the end of this range. Then this is the farthest integer which will be used to store the last index on which I can jump while I start from the current index. Then I iterate over the current range, that is left to right. Then I will update my farthest variable in this range. So after I run this loop, after I iterate over the current range, this farthest will store the index, the last index on which I can land while jumping from any integer in the current range or the rightmost point in the next range. That is what this farthest variable will store. Then here I am updating my left and right integers or shifting to the next range while I increment my answer variable exactly by 1. Finally, at the end, I will return the answer which will store the minimum number of jumps to reach the end of the array. So this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java and this is the implementation in Python. If you like the video, then hit the like button and subscribe to my YouTube channel. I will see you in the next video. Till then, take care. Bye bye.